We are given figure 3 where we are shown a line L and a circle C. It says the circle C has centre with coordinates 7, 5. We are also told the line L with equation y equals 2x plus 1 is the tangent to C at the point P as shown in figure 3. Part A is asking us to show that an equation of the line PA is 2y plus x equals 17 for 3 marks. So I'm going to start by highlighting some key information. The circle has centre A with coordinates 7, 5, so that is a key piece of information. I'm going to highlight the equation of L, which is 2x plus 1, and I'm also going to highlight that it is a tangent to C at point P. Okay, so first we are told that the line L is a tangent to C. And the reason why this is an important part is because if we were to annotate our diagram and draw a line from P to A, this line is a radius of circle C. So R and R equals radius of C. And from GCSE, you should remember that a radius and a tangent to a line at a particular point are perpendicular to each other. So, what is a key characteristic of two perpendicular lines? Well, what we can say as for part of our answer is, for perpendicular lines, okay, and in our case, our two perpendicular lines we're referring to are our tangent and our radius. The gradient of line 1 times the gradient of line 2 equals minus 1. So that means for our question that the gradient of our tangent, so we're going to use m for gradient, t for tangent, times our gradient of our radius, so r is our radius, should equal minus 1. So if we look now, what do we have to solve this question? We are told y equals 2x plus 1. So from here, what we can see is that the gradient of the tangent equals 2, okay, because it's y equals mx plus c. M is our gradient and therefore m is 2. So m for our tangent is 2. So what we can do is we can say 2 times the gradient of our radius equals minus 1, and therefore the gradient of our radius is minus 1 over 2. Okay. Now, remember, we need to find an equation for the line. So, there are a few ways you can use to find the equation, but the one I'm going to use is the following formula, which says that y minus some y coordinate equals the gradient times x minus some x coordinate, okay? Where these x1 and y1 is a point, comma y1 is a point on the line. Let's just fix that. x1, y1 is a point on the line. Okay, so if we come back to our diagram, we can see that PA is this line here, okay? And we can see that it goes through point A. Now for A, we know that our x coordinate of A is 7 and our y coordinate of A is 5. So that means we can plug in x1 into here and we can plug in y1 into here. So let's do just that. Y minus our first y coordinate is 5 equals m, which is minus a half from over here. So let me just put that in like that. So minus 1 over 2 times x minus, now our x point is 7. So let's write 7 like that. Now remember, we need to give it as a specific form, so we need to do some rearranging. I'm going to multiply both sides by 2 first to get rid of this minus a half here. So y minus 5 times 2, this is going to become 2y minus 10 equals minus, and then in brackets, x minus 7. Remember to keep your minus on the outside because we haven't gotten rid of it yet. Let's expand these brackets. So we have 2y minus 10 equals minus x plus 7. And this means 2y, we're going to bring this x here to the other side. So we're going to have 2y plus x equals, and then this minus 10, we're going to move it to the other side to get positive 10. So positive 10 plus 7 equals 17. That is exactly the form required here. So we're going to just write as required, like that. So this question is worth 3 marks. Your first mark comes from getting the gradient of your radius as being minus a half. Your second mark comes from combining your gradient of minus a half with the point 75 to get an equation in this form. So this line over here, down here, is enough to get your second mark. Your third mark comes from correctly completing your proof to get 2y plus x equals 17. Okay, so part B is asking us to find an equation for the circle C for 4 marks. So at the top here, I've just written some key information from previous questions that was given us to prior, so we can solve it. So to find an equation for C, we first need to recall what form C will take. So C is a circle, which means the equation it takes is x minus some center squared plus y minus some other, the y coordinate of the center, equals the radius squared. Okay, so to solve this, we need to find the center of the circle and the radius. Now recall point A was the center of the circle, okay, which means we know that x minus, so we've got our first x coordinate here, which is 7 squared, plus y minus our y coordinate of the center is 5 squared equals r squared. Great. So that's one bit done. Now all we need to do is find the radius. So if we look back at our diagram here, our radius is the distance between points P and A. Okay, so what we need to do is we need to find the distance between P and A. And how do you do that? Well, you first need to find the coordinates of P and have the coordinates of A. So let's start by finding the coordinates of P. Now recall that line L is tangent to the circle at point P, and PA goes through the point P as well, which means they share the common point P. So simultaneously solving PA, so line PA and line L, will allow us to find the coordinates of P. So let's do that. We know that L, y equals 2x plus 1, and for PA, 2y plus x equals 17. So what I am going to do is I am going to plug in our expression for y into 2y plus x equals 17. So what we will end up having is 2, and then our expression for y here is 2x plus 1 plus x equals 17. Okay, so let's expand the brackets. So 2 times 2x is 4x. 2 times 1 is 2. So 4x plus 2 plus x equals 17. 4x plus x, that gets us 5x plus 2 equals 17. 5x, subtract 2 from both sides, so we get 5x equals 15, and therefore our x coordinate equals 3. So to find our y coordinate, we can just put x equals 3 into either one of our PA or L and get the y value. I'm going to put it into L because it's already in the form of y equals something, so we have less to rearrange. So I'm going to say this implies that y equals 2, and then our x value is 3 plus 1, which equals 6 plus 1, which equals 7. Okay. So therefore, what I want to do, just to make it super clear to the examiner, is I want to say that P is 3, 7, like that, okay? Or P equals 3, 7. Either one is fine. So next, we need to find the distance PA. So the way you would go about finding the distance between 2 points is you would say the distance of PA, so this line denotes the modulus, which means distance, equals the square root of, okay, px minus ax squared plus py minus ay squared. Okay, so this is just sort of a more elaborate version of the Pythagoras theorem. So let's put our values in and solve this. Px is going to be, first the square root. Px is 3 minus, now ax, if we go back, come back to the top, we see is 7. Okay, so it is 3 minus 7 squared plus, now py is 7 and ay is 5. Okay, squared. So this equals the square root of 3 minus 7 is minus 4, and minus 4 squared is 16, plus 7 minus 5 is 2, 2 squared is 4, which equals the square root of 20. Okay, so what we can write here is r equals the square root of 20, and because remember, for our equation of the circle we need r squared, so therefore r squared equals 20. Okay, now we've got all the information we need. Let's just present it clearly to the examiner. So what we can say is equation of C is x minus 7 squared plus y minus 5 squared equals 20, like that. This question is worth 4 marks. You get your first mark for knowing that you need to simultaneously solve 2y plus x equals 17 and y equals 2x plus 1. So this step up until about here will be sufficient evidence to get you your first mark. Your second mark comes from getting p equals 3, 7, so as this. Your third mark comes from understanding you need to find the length of PA and getting root 20 as your answer. And your fourth mark comes from getting the full equation of C, so plugging in the point A as well as your radius, so that's your fourth mark there. We are told the line with equation y equals 2x plus k, where k doesn't equal 1, is also a tangent to C. Part C is asking us to find the value of the constant k for 3 marks. So we are told that y equals 2x plus k is a tangent. So what this means, when there is a tangent implies a solution exists. Okay, it just means that at some point they intersect and therefore it can be solved. So the way I'm going to solve this is I am going to end up by plugging y equals 2x plus k into our equation for C. But first what I'm going to do is I'm going to expand C to make it easier to substitute y into. So we have C is x squared minus 14x plus 49 plus y squared minus 10y plus 25, which equals 20. Okay? Then what I'm going to do is I am going to collect like terms. So I'm going to say x squared minus 14x plus y squared minus 10y, and then 49 plus 25 is 74, and then we're going to take this minus 20 from this side, this 20 from this side, and subtract it. So 74 minus 20 is going to be plus 54, like that. Okay, so what I'm now going to do is I'm going to plug in our y into here and into here and expand and solve. So we're going to end up with x squared minus 14x plus, and then 2x plus k squared minus 10 times 2x plus k plus 54 equals 0. Sorry, we've got equals 0 here. Okay, that's good. So let's carry on. x squared minus 14x plus 2x plus k squared. So first we do 2x times 2x, which is 4x squared. Then you do 2x times k, which is 2kx, and then you do k times 2x, so the other side, which is also 2kx. When you add those together, you get 4kx. And then you do k times k, which is k squared. Minus 10 times 2x is minus 20x. Minus 10 times k is minus 10k. Plus 54 equals 0. Okay, so now I'm going to combine terms and take out factors just to make it easier and simpler. So x squared and 4x squared. Well, this becomes 5x squared. We then have minus 14x minus 20x plus 4kx, which is going to be 4k minus 34x, so plus, okay? And the reason is because minus 14 minus 20 is minus 34. 4k plus minus 34 is the same as 4k minus 34, and we've taken x out as a factor. So then all we have to do is our non-x terms, or our constants, and this is going to be plus k squared minus 10k plus 54, like this, equals 0. Now the reason I've done it like this is because notice it is the form of ax squared plus bx plus c. Okay, so what we can do now is we can actually use our quadratic formula to solve for k. And the way we do this is we need to know, because it's a tangent, okay, we need to be aware that a tangent specifically implies one solution only. Okay, so this is key. So how do you use a quadratic to get one solution? Well, this means that the discriminant, or b squared minus 4ac, has to equal 0. Because if it's greater than 0, there are two distinct solutions. And if it's less than 0, there are no real solutions. Okay, so let's solve b squared minus 4ac equals 0. A is 5. B is 4k minus 34, and C is k squared minus 10k plus 54. So I am going to put all of these into our formula. So b squared, so 4k minus 34 squared, minus 4, A is 5, let's just actually neaten that up a bit, 5, and then k squared minus 10k plus 54, so k squared minus 10k plus 54, and remember this all equals 0. Okay, so let's start by going through 4k minus 34 all squared. The first thing to do is 4k times 4k, which is 16k squared, so 16k squared. Then we need to do 4k times minus 34, so 4k times minus 34 is minus 136, but we need to do it twice because it is being squared, so we multiply that by 2 to get minus 272k. And then finally, minus 34 squared is positive, 1156. Okay. Now we've got minus 4 times 5 times k squared minus 10k plus 54. So what I'm going to do is I'm going to combine these just to make it simpler to get minus 20, like that. So minus 20 times k squared, that gets us minus 20k squared. Minus 20 times minus 10k will get us positive 200k. Okay, so positive 200k. And minus 20 times 54, like this, is going to get us minus 1080, and this all equals 0. So then the next step from here is just to combine some stuff. So we have minus 16k squared, 16k squared minus 20k squared, and what that becomes is minus 4k squared. Then we have minus 272k plus 200k, which is going to be minus 72k. And then we have 1156 minus 1080, And let me just check on my calculator. That gets us positive 76, like this, which equals 0. Now I'm going to divide both sides by minus 4. So we're going to get k squared. So minus 72 divided by minus 4 is plus 18k. And then 76 divided by minus 4 is minus 19, which equals 0. So we are now left with a quadratic. So all we need to do is find two numbers which multiply to get minus 19 and add to get 18. So what I'm seeing here is to get minus 19, well, the only ones you have are either minus 1 and 19 or minus 19 and 1. But since we have 18k here, we know we need the 19. So 19 minus 1 gets us 18. So we're going to have k plus 19 times k minus 1, which equals 0. Okay? So from here, either k plus 19 equals 0 or k minus 1 equals 0. Well, if k minus 19 equals 0, we have k equals minus 19. If we have k minus 1 equals 0, we have k equals 1. But bear in mind, in our question, we are told that k cannot equal 1, okay? Which means, when we look here, we should write something along the lines of k equals minus 19 and 1. But since k cannot equal 1, therefore k equals minus 19. So the whole point here is you are showing the examiner that you are aware that there are two solutions, but because of the restrictions placed on k, you can't have k equals 1, and therefore k equals minus 19. This question is worth 3 marks. Your first mark now this question, actually, before I go through that, there are quite a few ways the mark scheme says you could solve it. And I chose the one which is probably more work, but it's a more straightforward or a more logical approach, okay? And if you are careful in what you're doing, it's probably going to be easier and sort of more reassuring doing it this way. So the first mark you get is for substituting y equals 2x plus k somewhere into your equation for c. So in the mark scheme, this line is listed as the final line, and that means if you include this, you have done enough work to get your first mark. Your second mark comes from knowing that you need to use b squared minus 4ac to find the solution to k. So you need to use b squared minus 4ac equals 0, or physically showing that b squared minus 4ac equals 0. So this line here is also sufficient evidence to get you your second mark. And your third mark comes from just getting k equals minus 19.